Hey folks, want to get talking about latitude and longitude, how to find our location somewhere on the planet. This will help us out in astronomy, especially with latitude. It's also a good analogy for the celestial coordinate system and for the alt-azimuth or local horizon system. So here's the deal. When you want to talk about your location on the Earth, it's nice to say, I'm in San Diego, but it's sure a lot more helpful to be able to describe exactly where you are. And we have a quantitative system to do that that's very similar to local horizon system that talks about latitude and longitude as the two systems, as the two different coordinates that give us a location on the Earth. So let's go ahead and talk about latitude and longitude. So first of all, the Earth spins, right? The Earth spins on an axis. We'll get to this much later in some detail. But because it spins, there are two very natural poles. It's sort of, you think about an imaginary pole sticking through the Earth from one end to the other, and the Earth spinning on that pole. That's our axis of rotation. And that axis of rotation, even though there's no pole there, goes straight through the North Pole and straight through the South Pole. So because the Earth spins, we have two very natural poles, and we can talk about those as a top and a bottom of a coordinate system. Then halfway in between those is the equator, right? So the equator is what divides the Earth into a northern hemisphere and southern hemisphere. Northern hemisphere going all the way to the North Pole, southern hemisphere all the way to the South Pole. The lines of latitude are measures of how far away you are from the equator. So, simply put, if you're on the equator, you have no distance from the equator at all. Your latitude is 0. And from there, we work our way up towards the North Pole and down to the South Pole, increasing in latitude. So as we work our way away from the poles, our latitude increases. The North and South poles are the most extreme latitudes you can have, and everything else in between them is somewhere between 0 and our extreme value for latitude, which is 90. So you can kind of think of them as an angle. From the equator to 90 degrees above is the North Pole. That's 90 degrees latitude. Same from going from the equator down to 90 degrees latitude. And yeah, we have to distinguish between and since it's 90 degrees one direction and 90 degrees the other, we have to distinguish which ones we're talking about. So at the north, we call 90 degrees north, and the south, 90 degrees south. Anything in between them is somewhere between 0 and 90 north, or 0 and 90 south. So what we see are these concentric or parallel circles between the equator and the North Pole and the equator and the South Pole. These are our concentric circles or our lines of latitude. There are a few lines of latitude that have exceptional importance or get a little bit more street cred than everybody else. And they're really important in astronomy. We'll be going over them a lot over the next few weeks. First of all, there is 23.5 degrees north of the equator. This is called the Tropic of Cancer. And then there's 23.5 degrees south. This is the Tropic of Capricorn. We generally call the region in between these two tropics the tropics. And this is where it tends to be really warm near the equator and pretty consistent year-round in terms of season. If you go to the very far north, we get the Arctic Circle, which has a latitude of 66.5 north. That's 23.5 degrees away from 90. That 23.5 turns out to be an important number. And we also have 66.5 degrees south for the Antarctic Circle, which is 23.5 degrees north of 90 degrees south. So those are our lines of latitude. So here in Reno, we're a little bit less than halfway from the equator to the North Pole. Our latitude is just about 39.5 degrees north. And you could get latitude for anybody, anywhere on the planet. And then we have our other coordinate, which is longitude. Right. Latitude tells you how far you are from the poles, but it doesn't tell you where you are on that circle. For example, if this is a map of all of the potential places you could be on the Earth, we here in Sparks, yes, we have a latitude of 39.5 north. but so do all of the other things on this line, like Washington, D.C., or Athens, Greece, or Beijing, China, or Pyongyang, North Korea. All of these have a latitude of about 39. We need a way to distinguish which ones we're talking about. So we need another coordinate. And the way to talk about where you are on this line of latitude is longitude. And longitude is 360 degrees all the way around the circle of the Earth and marking where you are on that circle of latitude. So these lines kind of show up as vertical bars. They all come together kind of like orange slices at the top of the Earth. So they all come together at the pole, and they mark where you are on those lines. The problem with longitude is it's a little more confusing because there's not an obvious zero longitude. We have to pick one. We don't have an equator of longitude because the latitude of zero is halfway between the North and South Pole. So now we have to just kind of pick a longitude and call it zero. And we did. We picked a line that went through Greenwich, England years ago, and this is 0 degrees longitude. From here, we just move away to the west or the east, and we increase in longitude until we get to the other side of the Earth, where we have longitudes of 180. So as you work your way east across Asia, all of those longitudes are something in the east values, so 70 east, 120 east, all the way up to 180. And same thing going west. You work 30, 70, 120, working your way to the west as well. And so we call the longitude values going east, the longitude number, and then E or east. When longitude's going west, the number, and then W. So longitude, again, these kind of slices of the pie that go from the edge, or slices of the orange that go from the top to the bottom, tell you where you are on those lines of latitude. With the two together, you can figure out your precise location on the planet. So for example, here in Sparks, we have a latitude of about 39.5 north and a longitude of 119 west. You could do this for any location on the planet. Lets you know where you are.